a very exciting chapter. Okay, this chapter will tell you basically two things: how to do segmentation faults and why we have segmentation faults. Plus one more thing was about virtual memory support. The virtual memory support can give you a lot of knowledge as well as wisdom in writing good programs. Okay, so here is the first challenge I gave out last time. I give you 2 printouts. Okay. And those printouts I didn't tell or didn't execute before you guys what should be things look like. Okay, so the printout is basically printing 2 pointer. I want to verify one thing. Do you know %p means pointer? Okay, why I print out the 2 pointer? These 2 pointers are supposed to be printing something the same, right? What is the same here is a constant called hello. Okay, so you can also edit this program, no problem. You edit it and try to print something more like the address of a local variable or the address to create one global variable, and you will find that this constant pointer, this hello, is not in any of the variable range. It is in this green guy within this area. It's born with the code. Okay, when you compile the code, it's born there. Okay, or if you know how to write assembly, it is in text segment. How many of you have heard of it? Text segment. No. So no one saw assembly. That's good. Okay, so I don't need to say anything about assembly. Now I want to ask you whether if I do the following, first of all, can I compile the code? Any warning? Can I do the following? I use a pointer to point to a string. It seems to be something good or not. Just like interview questions. You're doing something that is just okay. Yeah. Well, if it's okay, then it won't generate any warning. Now let's try. I first have a save this program. Then I make that program is called constant pointer. Compile. No problem. Now I have the warning turned on. I turn on the warning. No warning, no error. So that means that it won't check if I assign it into a pointer. Now some people argue with me, hey, is this a constant? Should I use a constant pointer to point to it? No. Okay? Constant pointer means another thing. It means the thing that you store in the pointer won't change after its initialization. Okay? So this is not about constant pointer or a constant. It's totally different concept. Now, if you don't understand what is the constant pointer, forget about. You can erase the record in your mind. Now, what I'm looking for is this statement. This statement seems to be strange, right? I usually do this trick, okay, to make you feel very uncomfortable that I have a pointer. And all people tell you that we can use pointer as an array. So I use pointer as an array in this statement, right? I treat it as an array. Now don't feel bad about what is a pointer. Pointer is just a starting address. Okay, so the starting address of this string, let's say it's equal to 1234, the address variable. It's contained 1234. Then what is the subscript 4? The subscript 4 means that I proceed from this position 4th slot. And what is the slot size? Char. Okay. So that means I just do address arithmetic. I have address 1234 is decimal. Okay. Then I add 4 1234. Advance to that location supposed to be where? Supposed to be the O. It's 0 HELLO. Supposed to be the O. Now I update a constant. And I get a compilation correct. Okay, so that means that it don't care, it don't assess this point before I really run it. Okay, and this is the dangerous code, and how the program or how the CPU respond to it. Let's go. Who think that the segmentation fault? Raise up your hand. Who think that my computer will reboot? Yeah, even more horrible. There is a bus, okay, a school bus error. Okay, no, it doesn't mean the school bus error. That bus is not that bus, okay. Yeah, you understand what is a bus? A bus is a set of wires in a motherboard, right? Because of bus, okay? Usually bus error means that you're using an address in a wrong way, okay? In Mac, it is a bus error if it is go to Linux. Let me find a Linux machine. Yeah. I will erase that part, okay? Ayya. I will erase that part, I'm sure, okay? No, I will change password tonight. Okay, copy, paste. Okay, so in Linux it's segmentation faults. In Mac it's bus error. So anyway, it's showing you something bad, okay, which is an error. And this error due from the range of that guy called hello. The range here tell you one thing, is a code and a constant. And in a memory, we have later on I will show you in a second part of this chapter. Every memory has its access rights, just like a file. File has read, write, execute, access rights. And here we also have read, write, execute, access rights. The same thing, read, write, execute. It's just like change mode, okay? And the mode that is changed for that range is read only, okay? So when you try to write it, boom, error. Can I read it? I didn't check the read part, right? So first of all, I add one more line to print the string. This is %s string. Okay, so this is the read part. I want to read the constant. Should be no problem, right? It's just a simple C program. First of all, I also erase these two guys. Okay, go back to my Mac. Compile, no problem. Run, no problem. It says this is hello. Okay? So the read, because it's read only, so you can read it. But it is read only, so when you try to update it, you can write it and give you some bad error. In Mac, it's called bus error. In Linux, it's a segmentation fault. Now, with this in your mind, let me do something even more horrible. The next example. What is the next example? Give you 1 minute to read it. Do you know what I'm doing? First of all, do you know what is voice R? Voice S3, I would say. Do you know what is this data type? This data type is called generic pointer. Generic pointer means that you can use it to point to whatever address you want. Okay? So main is a function pointer. Main is function pointer, so I use generic pointer to point to main, so as to I get a handle to the main machine code, the machine code of main. Okay, so this is crazy. They've gone crazy. What is crazy stuff about it? I point to the machine code of main and I start to read the machine code. In like 5, start to read the machine code byte by byte. Of course, I don't do it byte by byte in the loop, so I don't have a loop. I will continue to the next step. I haste that machine code. I execute, I write it. I override the machine code, okay? As if I want to override my source code, okay? Now, whether I can do it or not, no one knows. Let's try. Okay, so this is this program. Go access code. First of all, does it allow me to compile it? Good. Okay, moment of truth. I think I should be able to read, right? Because this is a code, it should read only. Now, whether I can update my machine code? No. Again, it's an error. Okay? So this part is easy to understand because the restriction is very strict, right? Whenever you want to write to it, it forbids you. Whenever you try to read it, it allows you. Okay. Now it's also giving you some sense in why sometimes you get a wrong pointer arithmetic for pointer control, but you can still get something working. Okay. It's just because some data range has some control. Is it read-only control or read-writable? Okay, both can read, both can write, or just read, or even just write. I mean, very seldom you just write and just allow read, right? Let's say you get a wrong pointer to the code and you try to write it, definitely you will get a segmentation fault. Now, what if you try to just read it? You will read something, but which is not something that you want. Okay, so this is some not insights, but some observation or experience. Okay, that I see many people is doing that. Okay, just have a random number put into the pointer, forgot to initialize pointer, and it so happens it's just point to a random location, and just try a lot whether you go to random location or want to read or want to write. Okay, now this is first part. Do you have any questions about a pointer reading? You're saying this time is a function pointer, previous time is a constant on the code. Okay, both the source of the code. Okay, now, by the way, give you a challenge. Okay, the challenge is extra. Okay, you don't need to do it. Okay, but my challenge is, I give you a challenge. Okay, so this is the thing that we failed, right? The thing we failed. Now, how about I do this? I just change 3 bytes. 1 byte, 2 byte, 3 byte is already up here. Okay? 3 bytes or 2 keystroke. Okay? Save. Make it constant pointer. Compile. What do you think? What do you think? Go to hell. Why? You just thank you. Thank you. I don't know. Okay. You can look up some C manual, really C manual. Okay, they will tell you what is the reason behind line 4, why it works this time. Previous time doesn't work. You use a pointer to point to it. No. You use this array index square bracket. It works. Okay? You will flip some manual. Okay, this is beneficial to you. Okay, beneficial to you means that you will learn something eventually. Okay, so I change it back to this. Okay, then we will fail. Okay, fail. No go to hell. All right. Then we go to data segment. Okay, we call it data segment. It's a segment in a Intel-based CPU. They call it data segment. And the data segment, we have 2 representatives. Okay, so these 2 guys are 1. We just call it global variable without any initialization, BSS. Okay, when you don't initialize it, okay, it will become a symbol in that area. Okay, it's just a name. You don't need to know why it's a symbol, why it's not a tag or not a string. Okay, but just call symbol. Yeah, they call it symbol. And other is data. Now, what is the meaning of data? Data means that your global variable carry data during the compilation. So what is the meaning? The meaning is, just like code, just like constant, global variable comes with compilation. You compile a program, you create an element, and the element is a global variable together with the data you hard code in your program. You understand what I mean? You're actually hard coding program variable together with their initialization value. So we call it data as a whole. The data with the variable itself. Okay? And the BSS don't behave like that. The BSS is uninitialized global variable. I just tell you that, yeah, I know that you have a global variable, but sorry, you don't give me any data. Okay, so we don't call it data. And now this is very clear. One is a global variable with initialization, one is not. Now what is the funny part about this? The funny part about this, as I said before, global variable comes with compilation together with the data. So I give you two programs. You tell me what are the consequences. Okay, so we will skip it and revise this later because I'm talking about something important. What are these two programs? These two programs don't behave differently, right? They do nothing. What's the difference? Where's the difference? The size. Okay? Are they initialized? Yes or no? Yes. How many elements did I initialize it? One or all? All. Okay? If I use this notation, it means the leading one to 10, and the remaining will be automatically become 0. Now, what is the meaning of automatically become 0? Is it become a set of huge data compiled together, put in your code, so that you can load into memory, or the program is so smart, I kept it in the first small program. I remember there is only a 10. Now, when you load it into the memory, I expand it automatically. Yeah, we have two choices. Now let's see. How do we know about this two? First of all, I have to disable the optimization because the compiler is smart. It's not that I create something, a garbage there. I didn't use it. So I disable optimization so that it will create this two huge, what is huge, what is not huge, memory space, okay? And I want to ls, what are the ls? The ls is to look at the binaries, the executable code, not the source code. The source code are just very close together, okay? So let's take a look at what is the name, I can't remember. Oh, data large, data small. Data large, .c, data small, .c should be close, right? They are .c file, differ by 4 bytes. Now, how about their compiled code? Huge difference. Whenever you get something initialized in your code and it's a global variable, it should come with your program, right? When it comes with your program, it's in the program, really inside the program, okay? And previously I asked the questions whether the program, when it loads into memory, it automatically expands the remaining zeros, or those zeros come with your program. Now you know the choice. It's not automatic. Yeah, it is by compiler. The compiler knows that, you have what is the size? I don't remember. Let me open the notes. Okay, the notes tell you that I have how many? 1 million. 1 million guys. Only one is not 0. For the remaining is 0. They will expand it for you. Okay. Now the funny thing is, what if I create an array of size 2 GB and initialize it? Yeah, you never thought of it, right? Let's try. Yeah, you know, OS course is like that, okay? Everything you have to try, but always I try. Yeah, you can also try, no problem. Yeah, the compiler won't explode your computer, right? Understand what I mean? The compiler won't explode your computer, but whether the program will. Okay. So let me try. Data launch. Okay, I'm sacrificing my SSD. Okay. 1024 is 1K. 1024 is 1 byte. 1024 is 1 G. And initialized. Okay. SSD. You never see a compilation take how many times? I don't know how many times now. More than 10 seconds already. My SSD. Oh, come on, baby. Give me some response, huh? Yeah, you understand, huh? You have to you can cheat your cheat your friends studying IE, SE, not CS, okay, they will be vanished, right? And then, I have a program very small, you gotta compile it. Oh, stop, okay? Woo. DU minus H is a human readable size reporting. Whoa, 1 GB. Run, so what? Yeah, let's run it. So what? Nothing, right? Because I don't use the data, right? It just goes to the memory and then consume the memory and go. Okay? Yeah, because I'm running the disk. I'm compiling it running the disk, so very, very slow. Okay? Funny thing. Yeah, this you fun, I'm not fun, okay? Alright, so let's go back to a few slides. I missed something, right? I didn't tell you what are the distance or what are the difference and distance. When they stay together, I mean that they are something related. When they are separated far away, they are different things. Okay, so the last week, last Thursday, I already tell you about this. And what is this scary face is telling you? Now let's take a look at this program. I just have a random screen dump here, okay? The true value may vary. I create three guys. First guy, local variable, okay? Second guy is a static local variable. Third guy is a global variable, all initialized, okay? And no arrays, so the program will be very small, huh? And let's take a look at this program. It's called global versus static. So the same program. Now I compiled it. Maybe I save it so that I can compile it. Global versus static. Okay, just some warning. I said that it should be long, okay? I just do some address difference here. Maybe you don't need it, okay? Then I execute it. So the global variable is by how many bytes away from the static variable. How many bytes? You have to do finger counting, huh? Oh, 8, and then 8 plus 4 is 12. Okay? Yeah, am I going to the wrong class? It's not literature class. Plus 4 is C. C is 12, okay? So that means the difference between the global variable and the static local variable are only 4 bytes difference. What can you say about this? What can you say about this? They are adjacent, right? They are adjacent, and static variable is a global variable. Okay? This is the conclusion. So what can you get about this? Did you get something really unconvincing? What's the meaning of unconvincing? I just named this guy a global variable. But while you are learning, maybe you are learning from me in a ENGG 110, the C version, okay? You learn from me that there is a guy called static variable. I never say anything about whether it's global or local. And now this is maybe the first time you see that a local variable actually is a global variable. Do you get me? Local variable is actually a global variable. And what is the meaning behind it? Now think about what is a static local variable. When you create it, in the scope of a function, it will stay there. Whenever you update it, it will keep its latest value without any changes when you finish the function. Does it behave just like a global variable? Yeah, the behavior is a global variable, but in the function scoping control, it's just like a local variable. So what is the static variable? Static variable sucks. Compiler control. This is compiler control. You compile the code, you want to access this global variable outside this function, story gives you compilation error. But as a matter of fact, it's global. I can use a pointer to point at this guy and change this static local variable. Okay? So I don't do it now, okay? It's overkilling. Overkilling is overkilling you, okay? Oh, I already got killed. Okay, don't kill me again. Okay. Yeah. So this is the truth of static variable. It is a global variable, and no matter where you are, you created I don't know for 10 functions. Every function get a static. They all behave just like global because their behavior is a global. Okay, it's just a function scoping. The compiler control keep a JO there during the compilation time, and execution time global. Okay, and this example I don't want to run it. Just to show you that with initialization and without initialization they're separated. Okay, but it doesn't make any difference, right? Eventually it's a global variable for you to use. Okay, and then we go to the size difference. Okay, and this is the size difference with initialization, and you know that huge difference. Now, what happened if I do this? Okay, what do you think? The previous case is like this, right? And take me 1 minute to compile a program. How about this? Okay, compile. Oh, no fun. Okay, they're just typical Hong Kong people. I want to see someone die. So. Want to see my SSD die. Okay, yeah. No fun this time. Yeah, you do initialize it, then it won't carry any data, right? So that means it's very funny, right? I can tell you a little secret. Okay, so the secret is how people write games back in 1990s or 1980s. They write games with figures, right? With 8-bit figures. Okay, they hard code those figures as global variable. Okay. And that's why in the 08, you play a program, that program is an entire game already there. You won't find a game contains a set of files. This is called a sprite, okay? There's a set of sprites there. No, they all combine inside the program as global variable, compile together, become a big chunk of thing, okay? So this is a thing that Nintendo was doing, okay? Nintendo no more now. Yeah, they sucks, okay. Yeah, only left what is that? The most happy games is 寵物小精靈, right? Yeah, you know. Still that way, okay. So there is a program in order to build this, okay, is giving you a report of what will happen while you compile a program. Now it's not about executing. So what is the program here? You call it size. Okay, the program is called size. We can try size, data launch. So it will give you some report. The report will be a little bit hard to see, so see my presentation here. Don't think that these two columns are different. Okay, they are just the same thing. Okay, with decimal and hexadecimal. And carry the data port, the test area. The test area means a code and a constant. The data, how big the program should be while we have the initialization for global variables, as well as the BSS. Okay, it's no fun because you are not executing the program. When you execute the program, then you will touch the two remaining areas, the malloc and the stack. Okay? Now this is something static, really static, come with your program. Any question you want to ask or anything you want me to try before I go on? Okay? If you don't want me to try something more, then I give you some shock. The shocking moment number one, you see this already, right? But you never see I create a program and I try to execute and touch those memory. Here, the same program that I previously formed using the data launch, okay? Also 1 GB area. And one more. Here, something new. Previous case is, I don't know where I initialize it, I don't care, but I try to touch those memory now. Okay, so what does it mean I touch those memory? I'm not going to read it, but I write it using MEM set, memory set. Okay, memory set is just that you can treat it as a for loop, and for loop will loop through every byte. Every byte will be set to 0 value. Okay, if you don't like it, I can set it to -1. No problem. But I want to demonstrate to you that I really want to touch those memory. If the system is not big enough, let's say I don't know why you execute this program in your iPhone, how many gigabyte of memory you have in iPhone 5 or iPhone 5s? 1 GB. Yeah, then you know what will happen. If I really try to access every byte in this program, okay? Now, but my MacBook Pro don't have this problem. I have 16 gigabyte. Okay, now show you one more. Yeah, show you one more command. Ulimit. The user's program limit. User's program limit here is called data segment size. Yeah, unlimited. Perfect. Unlimited. Let's go. Yeah, you know this OS course, huh? OS course is a S my program, S my computer. Go. Same program. Compile it. Oh, I didn't compile it. Sorry. Compile. I didn't initialize it, so it should be fast. Okay, so it should be fast unless I initialize it. Run. Okay. So I can show something more. Top. Yeah, to see the memory consumption. Update interval, set to 1 second, set to 1 second, okay. So what you should focus on, where is the memory column? Yeah, this is the memory column, okay, this is memory column. I set it to 1 second update, okay. I don't know whether my program is slow enough to show you, but I will try. Go. Hey, too fast. Okay, too fast. Okay, maybe I changed the program for a bit. Okay. Yeah, no problem. You know, I teach OS. Okay, I always get away. Okay, clean it and then sleep. For no sleep, get char. Okay, and what I want to do is I want to focus only the top show that program. Okay. Compiled. Okay, make compiled. Run. Okay, so this is PID. It didn't run. It's just waiting for my input. Okay, top minus P should be minus P. Oh, yeah, my bad. Process PID. Can you see the process PID? Where? Okay. Oh, well, minus PID. Minus PID. Good. Update interval 1 second. Okay. So you see, it's used very few memory because I didn't really initialize it. Okay. I just declare there exists such an array. Now, when I press enter, go. 有冇咁快啊 ？Okay, No problem, no problem. Okay, one more get chopped. Okay, one more get chopped. 403. Then I don't need to update the interval. Enter. Wow. Real consumption, 1 GB. Okay, kill. Okay. Try in your iPhone. Maybe iPhone 6s no problem. iPhone 6 is 2 GB. Okay, but you will have many apps got killed. Okay, except yours. All right, so this is something that will be setting our record on creating global variable, right? What is your record for creating global variable? Is it the record solver? I try one more. Okay, we are a scholar. Okay, we have to make assumptions. Okay, my assumption is I have infinite amount of memory. Try infinitely. How about this? Yeah, 2 GB. Nice. Yeah, that's why I said this part is the most amazing part. Okay, you will see how I break my computer. 2 GB. Compile. Can anybody tell me what happened? I cannot compile. Can anybody tell me what happened? If you don't know, I try one more number. Hey, sorry. Wait. Now this time I can compile. -1 can compile. Not -1 cannot compile. Can anybody guess what is the problem? Negative sign. So what is the meaning of negative sign? Overflow. Why is overflow? Can you guess what is the reason? Steven.
Because the number is overflow.
Signed integer. Yeah. So it's using signed integer for array size. Okay. Does it mean that we should stop here? No. No. Why we stop here? Why don't we try this? You stop me from creating 2 GB. No problem. I free 1 GB. Yeah. Come on. Yeah. You should be very excited, right? Because this is my computer. Get chart, okay. Also print a PID. Okay, PID. All right. One more get chart before the program ends. Before return 0. You guys. Very typical Hong Kong people. Okay. 4, 5, 3. Current assumption 272K. When I run this program, wait. Oh, I know. I shouldn't run in Mac. Do you know why? Only Mac has this problem. What is this? Yeah, memory compression. Yeah, Mac OS has memory compression. Whoa, let's try this. Yeah, nobody can stop me today. Yeah? Yeah, come on. Don't try in different machine. Try in my machine, okay? Okay, copy, paste. All right, make. Yeah, but it's my machine. Okay. I didn't reach there. Wait. All right, top. Okay, top is there. Top minus P. Ready? Should be P. I remember it's P. Okay, waiting for me. Good. Update interval 1. Go. How many? 3G. Then, what should be the next target? 60. I don't have so many memory, okay? Yeah, let's try 5, okay? 5 GB, no problem. Yeah, 幾興奮嘅真係，見到人揦嘢就興奮。Okay. D, E. Okay, this is 5. This is 4. All right. But the size of is wrong. Size of D, size of E. Okay. Now every array is 1 GB. Okay. But Then I have to check my physical memory limit. Okay. Big A. A? What? A against label A. What have I done? Let me check. Remove one. Oh, no fun. Eh? I don't care. This one. Okay. What you want is see my computer crash, right? 4-1. Update interval, 1 second. Go. Ooh, 4 GB. Okay. Wow. Yeah. Homework. Try your computer. Yeah, I want screenshot. Okay. I don't type this out. Oh, copy and paste and modify it. Yeah, I get it. Okay, 8 GB. Okay. Yeah, what is the size of my computer? 3 minus M. I have 16G. Actually, in my Linux, I have 16G. Huh? You try later. I have to teach. Come on. Come on, I have to teach. Yeah, this sign integer, you know. I can try this something. Okay. Go home. Now this time you can try in your computer or department computer. Now what I have tried is in 64-bit CPU, okay? Half of 32-bit. Half of 32-bit. We never try, right? Go home or go to department, find one 32-bit computer, execute my program, try 2 GB, 3 GB, 4 GB. Okay? Which gives you successful case, which say that it's being killed. Okay? It's not about department. Okay? It's about 32 bits. Think about it. Okay? I already said that 32 bit has some limit. Okay? Interesting, huh? Really interesting. I also feel interesting. Okay? Next time we will continue to talk about the stack as well as the malloc. The malloc is the most important of all. Okay? Because you always use malloc to grow your memory, but you never know that it is a linked list. Malloc is a linked list. Okay? I will teach you how it builds its linked list. And the stack, I will go through it fast. Hopefully, next week, we will step into the virtual memory support and end this course in week 13. Week 13, remember to come back, we will talk about the final exam. 13 is last week, okay? Oh, see you next week. This